Inline functions in C++ are the type of functions. We define the inline functions with the inline keyword, and this suggests compiler to insert some functions code at the point of each call rather than performing a regular function call. It reduces the overhead of function calls, and this is for the small and frequently called functions. So we will see an example here. So we begin with #include, and we will say IOSTREAM, and we will define the inline function that is to be defined in the main file. We write this inline int and int a int b, and we have the curly brackets, and we will return a plus b. This is our result. We're just adding here, and we will continue this by copying the codes here. The next one will be the multiplication. Here we have a multiplication sign, and let's do the division. That works. I think this works as the division. And we can also do something like so here we have to do multiply. Let's see, right here the multiply. Let's say division. And let's make a inline recursive function, and then we say inline int factorial int n, then we say if and some operators here, 1, then we return 1, and if some conditions are okay, we do the factorial n minus 1. So this is a recursive call. And here for the recursive call, now inline recursive function. So compilers don't inline recursive functions, and we can also have an example of non-inline virtual function. So this will not be inclined. So in this case, we do not write the incline at the very beginning. So we do class base, curly brackets there, public, and virtual, then void, and so, and we print something with some operators here. And let's say this class function. And again, some operators, std, colon, and l, and then we have the curly brackets at the very end, and we're seeing some problems. So line 9. So I think this is somewhere here. Okay, let's see. Line 9. So here, we should not do something here. So we should do something here. We are not closing the function. So this is the first function. Then we had the second function. And then we had the next function here. And that's it. It says expected a declaration, line 33. Okay, and then after that we have so we hadn't closed the curly brackets. Okay, and then we had this non-inline words function where we have these curly brackets here, and then we need to have so this is still showing some errors. So TD and L. So it says C line 20 something is not working correctly here. So we have inline int factorial int n, and there's some condition. The spelling is incorrect here, so we have to return 1, and then we return n multiplied by factorial n minus 1. So it's okay here. So it's now saying line 30. So we have some extra curly brackets. Now this will do fine. After that, we have the next class. So let's write here class derived public base, and then we have public again. And now we write inline void show, and this is override, and so this is marked as inclined, but cannot be as it is virtual. VUAL virtual, and we print something here, std COUT, and then we have derived class so function, and some operators, std colon and l, and then we have the curly brackets here, and we also need another curly brackets like this. So it's saying problems again, and line 34, and column, we're going to have the spelling error here, so this is overwrite. And after that, we can now, so let us add some other inline functions as well. So we have different inline functions. The first one was to add and the two numbers. Then we have the inline function to multiply. Let's make another inline function to calculate the square. So this will be the square. We will simply copy this like this. Then we say square, and the number will be, let's say, x, and we will do x into x. Then we have the inline function to multiply, where we do we just do the multiplication. So we have some code load here, and then we had the inline recursive function. This is where the compilers don't inline the recursive functions. Then we have the non-inline virtual function. So this will not be inclined. And now we will try to use the functions as int, main. So int, so we have a is equal to 5 and b is equal to 10. So we are providing the variables to be used for the function. So it says line 65, line 47. So we have some Chrome here. So let's return 0. return. And then we have this like that. And so it is still saying something as line 48 from 5. So this is missing here. No, it's okay. So this is the first one. So we will call the inline function. Call function function. So std cout and say addition of two numbers. First one is a, and the second one is b, and we'll say is and a. So add a b. So we are using that function add a b, and we will say today and DL, and this is the first use of the inline function. Then we will call the next one, that is int. Let's see what we have here. That is int x. So x equal to 5, let's say. And this is for the square. Now let's print this. Let's copy this again and print the results. So std square of x is, we have square and x here. So this is the squaring. We are calculating the square of a number, and it is showing some line 52. So there is some error here. So there should not be this like that. And it is still showing some problems here. So expected a colon. So and why is it showing the error? Std line 52 colon 5. Okay, so you'd say I can't find this one. I think everything is okay. So square and expected squares. So let's see, this is the x and square x. Square of x is square and stay and stay square of so I can't really see what's wrong here. It is saying expected the end here, but I think it's something else. So it is to let's write something, add something here. Maybe this will help. Square x is square and then std COUT square of x is. Let's write this again. So this is the problem here. I haven't done this one, so I need to write or complete each line with the semicolon. Now it's fine. So that was what this was doing some or creating some problem. Then we call the inline recursive function. This is the factorial. And let's say int. So I have the int as the number equal to 5. nst cout is factorial. Factorial factorial. This is, we have to use factorial here. And factorial is the name of the function. So we will say factorial t or factorial, and we will provide this number. So we will also see the virtual functions that cannot be inclined. And so we have the best TR, and we'll say derived BRIVED DERIVED O BZ BASE PTR is equal to end derived object. Then we do BIS PTR and this S. So, and this will so this is not inclined. Not inclined. So we will run this and see what it will give us. There are 6 and do G++, and it is showing some error. So I didn't in one exit status. Okay. Anyway, this is not the target here to run this one. We are just trying to learn some of the type of functions. So we have the inline functions, and we did the add, square, and multiply, and these are defined in the same file and can be inlined by the compiler. We also have the recursive inline function, such as factorial, but it is unlikely to be inlined because inlining recursion can cause issues with indefinite expansion. Then we have the virtual functions that cannot be inlined if they are called polymorphically, that is through a base class pointer. So derived colon so will not be derived colon so is inlined, but this won't be inlined when we called via a base class pointer. So the uses is that the inline keyword is used before the function definition. That's the main thing we need to understand. And it tells the compiler to attempt to inline the function. While we use the inline keyword, the compiler may or may not exactly or actually inline the functions, and it depends on factors like functions complexity and size. And the inline functions are often defined in the header files as the function body needs to be available wherever it is used. So the compilers needs to know the function's definition to inline it. So this is, and there are some benefits regarding the inline functions. The first one is the speed. It reduces the overhead of function call. and also it is useful for optimizing. It can improve the performance for frequently used functions. There are some drawbacks. The code size increases, and debugging might be harder. And this is it. We could not run this. It is still showing some error here. Maybe I'm not doing something right. So this was an attempt to learn some of the things about inline functions. We will continue our learning.